Hey, editing guy here. The desk guy, Jason, got to sit down with Jim Truher, one of the original PowerShell team members and the creator of PowerShell Crescendo, to dive into the internal module generated by Crescendo. No surprise, Crescendo was written in PowerShell, and the module artifact it creates is also written in PowerShell. The reason for this? You can use all of the PowerShell tools in the ecosystem to further enhance your modules. You want a progress bar? Add it to your module. Crescendo is a solution accelerator, and it doesn't prevent you from adding the fine touches that you want. So enjoy the deep dive into the generated Crescendo module with Jim Truher. Now back to the desk guy. Hey, Jim, thanks for joining into the meeting today. Hey, look, Crescendo has turned out to be a remarkable framework for helping people basically wrap native commands and turn them into PowerShell commandlets so that they can work with them in automation easier, and they can make those native commands join into the ecosystem that they love and respect so much. As the creator, inventor of, and the lead engineer for Crescendo, I wanted to have a chance to ask you some questions. A lot of folks they're using Crescendo, they're getting the native commands turned into commandlets, they're really enjoying it, but there's kind of a mystery wrapped around, Crescendo creates these artifacts, a module and a manifest. And so I'm getting a lot of questions like, can I only do the things that Crescendo features provide, or can I do other things that the PowerShell ecosystem lets me do? Like, could I have progress bars and stuff like that? And folks are asking, can I edit the module? Is it encrypted, or is it in binary? Is it something that I could adjust to add more features to? So basically what it comes down to, Jim, is what I'd really like to understand is, after the export, what is Crescendo really doing in that module? And is that something that I can add to, that I can improve upon, stuff like that?
Oh yeah, absolutely. In fact, the design of Crescendo was to be sure that we gave the person something that they could modify if they wanted to. You have complete control over the code. Crescendo is just putting together the parts that are needed, so it knows how to construct arguments that the native command would use, starting from the place that PowerShell needs parameters and values. So you absolutely can change any of that, and in fact, that's one of the reasons we're going to go through this. We're going to go through all those points where you can interject your own changes or extensions, or however you like. Crescendo is just simply there to accelerate the process, to provide this framework for you, so you can customize it to as much as you want.
And really, that's kind of the point to Crescendo, is that Crescendo is not your complete solution. This is going to do everything for you. That's not its intention. It's tooling and a framework, just like other things in PowerShell, where it's to help you accelerate. So in other words, a lot of folks, they don't know how to, through code, wrap a command or invoke a REST method. But Crescendo takes that heavy lifting away from you, but still, you are still the author of the module. You still have complete control, right?
Yeah, absolutely. I mean, there's shades of gray here. It is certainly possible that there are some wrappers you might want to write that are complete and don't need any change whatsoever. And we try to handle as much of the normal case where we can. But things can get really complicated if you want them to be, or if you have some specific needs for how you want to have this particular wrapper that you're building work for you. So for the most part, I think if you're talking about a percentage perspective, I would say 80%, maybe even more, will be not needed change. Maybe it's 90%. You won't need to change anything, but you can if you want, and if you know how the module has been constructed, which is why we're doing this, so we can kind of describe what the various parts of this constructed module are.
Well, and I think I would totally agree. My experience has been that, 80%, probably more, as you said, than 80%. Crescendo builds what I need and I'm good. I can use it in automation. It makes my life easier when I'm using it interactively. But I've noticed that, it's not just other folks asking, but there are a couple of times I run in, I'm like, boy, I might want a progress bar. I might want to do this or I might want to do that. And if that is my desire, as the author, this is a module that I can read. It's in PowerShell and it can be modified. I think understanding more of how this module is constructed inside would really go a long way in helping me understand this. So could you start us from maybe a configuration, a typical JSON configuration file for a Crescendo that to wrap a native command, and then take us through that export and then show us inside of that module?
Sure, absolutely. Let's start with if config. Let me share my
Oh,
screen.
outstanding.
So this is the if config configuration. This is actually being written against our next preview, so preview 2 of the 1.1 release. So it has a couple of new features in it
Oh,
that
good.
we'll talk about as we get closer, as we move through the thing. So this is a standard configuration for Crescendo. You'll notice that the schema has been updated to later schema because we've added support for a number of new things. So it's all very, very straightforward. It is we're gonna be running if config. So I've named the verb invoke and the noun is if config. And one of the things I like to be sure that I do when I'm writing these things, although it's very easy to leave these out, are descriptions. One of the things that Crescendo does is it will build comment-based help. And so it allows you to um, encode what you want this to do descriptively into the module, and that can be really useful if you have something and you don't touch it for 6 months. You come back to it and say,
Oh,
"What was this really doing?" So I can
absolutely.
really do it. So that's what the description is used, and the original name is the actual binary that we're going to be running. And in fact, if you hover over if you hover over that element in the schema, you can see that there is a description there for it. So it's the native command that going to be called, and we can create aliases for it as well. And we have a little usage statement. So when you use get help, it will actually give you a synopsis. This one isn't very useful, but there you go. Then there's a block of parameters. And this
Oh,
is
yeah.
the parameters in this particular case, if config. This is the if config for Mac and Linux. The command itself, if config, does not have a parameter name for the interface that it wants to retrieve. So
You mean when I'm typing ifconfig space en0 or whatever?
yeah, if I say if config en0, that en0 is a parameter value. It's an argument, but it doesn't have a name like PowerShell does.
There's
PowerShell
no
has
there's no dash or slash parameter name, nothing like that.
nothing like that at all. In fact, it's just a positional thing. The ifconfig application and many native applications don't have a parameter name for every sort of argument that you can give it. And that's actually really important to difference between PowerShell and native applications. Is native applications may have only a positional type of arguments where no parameter name is required at all. PowerShell, every argument is going to have a name. Every parameter, every argument that you pass to a commandlet is going to have a name. It has to. It's part of the definition of how PowerShell works. You can associate positions with a parameter name. That's certainly that's doable and very common. get child item, for example. Path
Path.
is the
Yeah.
parameter name for in the path that you want to get the child items for. And so you don't have to include that parameter name. You can just uh, um, uh, type the dot, get child item slash, or whatever you like,
Whatever that argument is.
and yeah, whatever the argument is, and we map that to the path parameter. So we have to find a way, and one of the things that Crescendo does is it tries to build a map between what the parameters are that PowerShell thinks of as parameters, that everything has a name, and some could be positional and some may not, and what the native application sees as arguments. So we actually have to figure out where to place a positional parameter, for example, if it is a positional parameter for the native application. And PowerShell and Crescendo has a way to enable that. There is an original position property in the parameter for the parameter that allows you to kind of specify whether or not this thing goes at the end or at the beginning, or where you want it to go. And so if you look at this particular configuration there for interface, there is no original name. It is one of those. It is one of those things that does not have a parameter name, and if you try to use one, it'll cause an error in the invocation of ifconfig. So we can't provide one. So we have to make sure that we set it as an empty string.
Now, I think this is really interesting and really important. A lot of the native commands that I've worked with do have parameter names. So an original name, I have that native command original parameter name. But as you point out, a lot of them don't. ifconfig is a great example. And so it is just as common to see original name as just two quotes, blank.
Yeah, absolutely. Depending on the native executable. Another thing to mention here is this is where you can kind of do an impedance match between those parameters which use two dashes, like the long ops in a number of utilities, where you'll have minus help,
Mm-hmm.
or this is where you can smooth over the difference between PowerShell and those native applications that use minus. So if you, for example, wanted to add a parameter help, you could name the parameter help, and the original name would be minus help. And that way, PowerShell will present you a parameter minus help, but it will map into minus help, and that way you can kind of match up the parameters of what PowerShell thinks a parameter should look like versus what the native application thinks what it would look like.
And I think that just in that example itself is a great example of being able to kind of obfuscate that the way that a native command operates from the way that PowerShell operates. So if you have folks that are really accustomed to the PowerShell ecosystem, you can get rid of some of these things that would confuse them, like long opt type parameters, dash help or dash whatever it is, which is not common in the PowerShell ecosystem. You can remove that. I think that's really cool.
Yeah, and in fact, a lot of it is not unknown for both long op and short op to be used in a native executable. So you could have some parameters be minus help, and another parameter for that could be minus L, for example. So you could have minus and minus L and a single minus in the same command. So that's one of the things that Crescendo tries to smooth over, is that the differences in parameter handling.
But I also noticed I also noticed something else in your parameter list here. You've got interface, and I've used ifconfig. That makes sense. But you've got something I don't think ifconfig has is a filter.
That's right, and this is one of the new things that's coming in preview 2. Is this next parameter. Actually, filter does not belong to belong to if config. There is nothing that I can map to, but this I still want to be able to filter the results, and I can do that in my output handler. We'll show that in coming up. So this parameter called filter, it's an invented parameter. It doesn't exist anywhere. So its original name, of course, is again a blank, and I have a default value, which is dot star, which is going to turn into a regular expression. I'll show you that in the output handler. And then we have a new attribute for a parameter called exclude as argument. And if exclude as argument is set to true, it will not be passed. Nothing about this parameter will be passed to the native executable.
Which
by default
is kind of a good thing, because you just said filter doesn't exist on that native command. So if we passed it, you'd get an error message. So
correct.
This will exclude it from the command and then throw it into the output handler?
Well, it's actually just now generally available. It's a parameter value, like it's a regular script function. It's a regular function parameter value. So it's going to turn this into a parameter called $filter, and you can then reference $filter anywhere in that function in the proxy.
So
anywhere.
Essentially, you're creating parameters that aren't used by the native command, but you could use in the output handler to adjust things, in this case, like the format. So instead of taking the native command that you've wrapped with Crescendo and then piping it to like a where object as a filter, you can do this filter in the output handler so that the end user doesn't have to create some custom filter. You can do that already for them.
Exactly, and that value would then be available to the output handler or any other code if you want to do more customization in your module. It doesn't have to be in the output handler. It can be in the output handler, but it can be anywhere you want to use it. You shouldn't need it in elsewhere in the proxy, but you can get to it, because it's just another variable in the scope of the proxy function. And I was going to say that exclude as argument is default to false. So by default, any parameter will go off to the executable. But if you set exclude as argument as true, we will exclude it as an argument to the native executable. Now that we have these parameters all defined, we can now go down and look at our output handler.
Yeah.
Our output handler is a fairly simple output handler. It's a streaming output handler, which means every line that ifconfig emits will be sent into the handler. It won't store up all the results to the end and then hand all of the results at one time to the handler. It will actually stream them. So that's notated by the stream output is set to true. And then we can actually see the handler, the implementation of the handler. And I'm using a command on Mac called JC, which has a large number of text converters that allow you to take the output of a large number of utilities and convert them into JSON. PowerShell is really good.
Yeah, this is probably a really good point for you to, re-explain, maybe add a note here about, one of the greatest benefits to Crescendo is your ability to wrap a native command, but the biggest benefit is being able to take that arbitrary string output that's really hard to work with in automation, and turn it into structured output objects, essentially, that you would expect in PowerShell and you can use. And what JC is helping you do here is take some of that arbitrary text from that command and make that structured conversion, right?
Yeah, that's exactly right. In fact, JC supports a few dozen different utilities that emit text, and it will convert it into JSON. Now, JSON is a really good thing for PowerShell. We like JSON a lot. We can convert it into objects, and that's super useful. So rather than building your own custom formatter, if
Yeah.
under some circumstances, you can use one that already exists. And especially in this particular case where 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 we know what the output is, it's supported. We don't have to build a custom converter of text into objects. We can just use JC. So that's the reason why I've used this as in the example, because ifconfig is one of the things that JC supports. So I'm going to use it. And JC is a project on GitHub, so you can go and get it and use it. You can install it with Brew. I assume you can install it with APT. Um, it's a great utility, and all we need to do in PowerShell is to take that output and convert it, call convert from JSON on it. So all I do is
Well,
take the input, pipe it to JC, and then I convert it from JSON.
I think it's an
What
important note that one of the benefits to Crescendo is your handler type could be a script or a function where you write your own output handler if there isn't one available. But this is a great demonstration of, hey, if I can find a way to automatically to help me handle that output, get it into JSON, into a format that PowerShell's, excited to be able to handle, then I don't have to do all that custom writing. But you can if you need to in Crescendo.
Absolutely right. Absolutely right. And the next thing that we do, and this will be kind of this will kind of show off why we do it when we actually run this. I add the type name crescendo.ifconfig to the output of that JSON of that object. So what this allows me to do is now use our formatting subsystem in a little bit later. I'll show that. And so I can build formatting for the output that comes from the ifconfig output that's been parsed. And then finally, at the end of this output handler, we have our filter.
Oh, that's okay. And that's how that filter then works to filter the output that you set up as that excluded parameter from the arguments.
Correct. Remember that the value $filter, it's a parameter, so that means it's in the scope of the function, the proxy function. And so now I can just use it in the output handler. And in this particular case, the way I've set it up is that it will filter the output, the incoming objects that were built through this earlier pipeline of JC convert from JSON and add member. And I will look for the name property and match it against filter. And since the default value for filter was $star, it means that I am going to get everything. Now I could have used -like. My preference is for regular expressions. I find them very powerful, but you could have used like, for example, and that would be fine too. It's kind of a stylistic sort of thing. What do you like to do?
Right.
And that's all there is to it.
Now,
So that's if we go back, that's the entire configuration.
yeah.
And what we can do is we can turn the crank and we can type export. We can type export Crescendo module given this this configuration, and we can build a module of it. I did that earlier just to save a few seconds here.
Well,
And
but before you turn the crank and export this little dude, I just want to point out that, you can hand write these JSON configurations. You can copy one and modify it. Also, the Crescendo commandlets, and we have documentation on this, will help you build this initial structure so that you can go in and fill this out. This is very human readable, Jim. This is very relatively straightforward for somebody that works with PowerShell. And then at that point, you're ready to turn it, make the magic happen and turn the crank, as you say, by exporting it.
yeah, that's right. That's exactly right. I just wanted to make sure I knew what directory I was in. So let's make sure that we can actually turn this crank. We're going to create that, and then it's going to be, yeah. This is going to be a sample in our output. So I'm going to turn the crank and create the module. So I use export Crescendo module, give it a module name and the configuration file. And I'm using -force because I actually did this before. So I'm going to overwrite what I have done. So I'm going to just do this, and that should turn the crank, and I should now have a new module. And this new module has a bunch of information in that's very, very useful. One, we know that it's been created by Crescendo. The banners, the top of the line says so, and we know what version it came from. We know the schema that we used. I think over time we may have more than just 2 schemas. Depending on how many changes we make, we could have a number of schemas. So moving back, if you have a very old Crescendo module, you will probably want to know the schema that you use, and we will also be able to tell you when that was generated. We want to include the generation time because you could use a different schema to pay based on what time it is. So we can't just use the date of the generation. We have to use, if we combine the 3 things, the version, the schema, and the time that you generated, you can kind of figure out where that came from.
Word. And you know what the best part about this is, now that you have this module, is I can read this. It's not encrypted. It's not in binary. It looks kind of like PowerShell, although it looks a little chewier than how a module looks when I write it, but this is very usable.
Sure. Yeah, that's for sure. There's a lot of boilerplate, and remember that what we're trying to do is smooth out some edges so you have a commandlet experience with a native executable. And that means we have a lot of work under the covers to smooth those edges out. And that this code has to capture all that because this module is now completely standalone. It's yours. It's the authors. They can do whatever they want, but we need to have a bunch of stuff here because we make reference to it from other places within that wrapped command.
And I really want to emphasize that point, is that when you ran export Crescendo module, that's where you need to have the Crescendo, the official Crescendo Microsoft.PowerShell.Crescendo module installed so that we can generate it. But as you said, once this module is generated, it's completely standalone. It can run anywhere where that native command exists. You don't have to have the parent Crescendo module around any of that. This is completely standalone. So getting all of that data out of that configuration spun up in here, that's what makes it look a little chewy.
That's correct. And as we get close, and as we get down into the parameter map, that's where it gets super chewy because we need to store a lot of information. So we actually have this custom function attribute that we store, and it allows you to query your modules to determine whether or not any particular function is a Crescendo function because we add this attribute. So it also captures whether or not the command needs elevation, which can be something to really be useful when you're trying to use tools against unimported modules. We can start looking at this first function, which is called pop Crescendo native error. Crescendo has in 1.1 has the capability to present errors in the native executable as errors that are coming right out of the wrapped command, the proxy function. And pop Crescendo native error is the tool that actually does that for the function. So if you look at this, if we kind of take a look at it, there's 2 main branches in it. There is this emit as error branch, and then the else, which is just dequeue the error. If we have emit as error, and we actually do by default at the bottom, and I'll be showing that in a little while, we will actually show the error coming out of the proxy function, and we'll talk about that in a bit. But this is how this code is done. It actually creates an error record, and uses $ps commandlet.write error, because this runs in the context of the proxy function. It will use $ps commandlet to be able to do that. And this is the way we show errors and how you get access to errors. So, for example, if you use emit as error, it kind of participates in the normal error output process. If you don't use emit as error, we will hand you back the error that we found, we got, and that means you can use it directly in your output handler. This example doesn't do that, but it is possible to use to pop that crescendo error, and you can just get those errors back to your output handler, and you can do custom handling.
So,
in your
okay, so
output
you can
handler.
enact as something else upon that error if you
Correct.
want. So, okay, great. So either we can admit it as an error and it's all trackable through PowerShell, as we're going to see. We can use get error on it, that kind of thing, or we can leave it in for the output handler and then enact some kind of routine for it or something. Oh, I like that.
Right. For example, if you're doing some streaming and you actually want to act on the error as you're executing, you can check to see whether there are any errors, and if there are, you can actually grab that error and present it to the user, or take a different action, or store it to a log file, or what you want, whatever you want to do with it. You have the opportunity to do that in your output handler.
Right.
So the next bit of business here, the push crescendo native error, is how we get those errors into the queue. And so this code takes, and we'll show this in just a short bit, takes both output and errors, and if it is an error, it will enqueue the error and not emit anything. Otherwise, if it's just standard output, it will emit the standard output. So this is built as a filter. Filters are used in PowerShell. They've been there since version 1. They are essentially the implementation of a script commandlet that is only a process block. So this takes line by line. It will take input and then either I emit it if it's just regular output, or if it's an error record, which is what we get if there's an error generated by the native command, we will enqueue that into the collector, or the bucket of native errors, and then you'll be able to act on it. So we'll come up to we'll show that in just a little bit that'll make more sense in just a moment. Here we come on to the function the function of the main proxy. This is the invoke if config. This is what was generated, the code that was generated by the Crescendo module based on the configuration that we looked at.
Now, I have to say, you keep using this word proxy, and I just have to, so you're referring to proxy commands. This was something I think that came out around the PowerShell 2.0 timeframe, the ability to essentially, if you had the way I remember it was, if you had a commandlet that had existing parameters on it, you could do a proxy command, which let you wrap that commandlet and add your own parameter with your own functionality to it, just like it came from Microsoft. And you can then ship that around your company and people could use your newly found. I never thought of using proxy commands to wrap a native command, but is that essentially what you're doing?
That's essentially what I'm doing. I'm not using in PowerShell, we actually have some APIs that are available for the user to create those based on an existing commandlet, but it's the same conceptual model. I am invoking a native command through PowerShell, and I'm dressing up all of the parameters, and I'm dressing up all of the invocation in the same way that you would do with the proxy with the proxy commands that we have. So I keep referring to it that way because that conceptually in my mind, that's really what's going on. I'm simply I'm invoking by proxy the native command, and this proxy this function is the thing that that enables all of that. So that's the reason why I keep calling it a proxy. It never has kind of come unstuck from my brain, because that's really in essence what it is.
But I think this is really cool. You used PowerShell to build better PowerShell.
I guess I did, yeah. So one of the things that happens in the code generator, that's the actual Crescendo module, is that we generate the parameter block. So this thing right here gets generated based on this configuration that we looked here.
Right.
Based on all of this, we created the parameter block, and you can see a couple of things that remember we had a default value for filter.
Right.
So we add two things. We add that default value for the filter, and we actually create the attribute so it can be used with some of the get command tools that allow you to determine what default values are and things like that. So it can be pretty complicated. In this particular case, it's pretty easy, but it can have positional parameters, and you can have any sort of validation that is supported in a PowerShell function or a PowerShell script. Any sort of parameter function, parameter validation that you want, you can actually add to the configuration.
Oh,
you can add positions. Yes, absolutely. Yeah.
Now, see, this is a great example of one of the questions that was coming in was, Crescendo, when you configuration file, it itself doesn't have components to necessarily add in, validate, set, and all of that, but you can, because it's a part of PowerShell, and that's one of the true natures of this. This module is a PowerShell module. You have all of those PowerShell capabilities still available to you. So yeah, you can add all of the validates in here.
Yeah, absolutely. You can actually not just add it here in this, but you can, the configuration,
We'll take it,
actual
yeah.
configuration allows, we shortcut a couple of them, like position. We provide parts of the parameter schema that allow you value from pipeline, those sorts of things. But we also have an escape hatch, which is I think it's called parameter attributes or additional parameter attributes in the schema for the configuration, and you can put whatever you want as a set of strings. You can add those, and we'll simply add them. We don't supply shortcuts for all of them, like validate, set, or any of those things, because they can get rather complicated. But if you want them, you can create them yourself, add them to the configuration, and we'll just put them into the parameter declaration.
I love the flexibility.
Right. So as we go, now that we've got those parameters all sorted out, the next thing that the code generator does is it actually starts the begin phase. We create a begin block in this proxy.
Wow.
And we're going to talk about a couple of things here. There's a new function in PowerShell 7.4, I think, or maybe late 7.3, called there's a feature called native command use error action preference. We actually set that to false because when set to true, two errors will be generated. One gets handed to standard output, standard error, but the other one gets converted in, but that same error is also converted to an error record. And in this particular case, we are already managing our error handling. So we just want the standard error only. We don't want the additional error record that we display to get in the way here. We don't need two errors. We just need the one.
And if they had this set to true, this might be a situation where you might see two of the same error messages spitting out as opposed to just one. Okay, great.
That's correct. And then if you remember in the next line 55, if you remember up in these pop crescendo and push crescendo, you recognize this crescendo _ crescendo native error queue. This is where it gets created, or where it's initialized, I should say. We create this queue in the in the begin block, because we want to be sure that all the errors for this command, this proxy, aren't shared across any of the other proxies. So this is all done to be sure that everything keeps separated, so we don't
Yep.
share errors.
Everybody has their own little
correct
queue of errors. It's
remember
not one
that
group thing.
Right. Remember that a module can contain many different many different functions, many different proxies. We want to be sure that each one of those has their own errors. So that way, if you didn't drain it, or you didn't drain the error queue, or if it was shared between all the proxies, you could have you might have some aberrant behavior that can occur.
Right.
So the next big chunky block of code here is the parameter map. This is the parameter map. This is where we store away all the information about how we map the parameter that we present to the user to the arguments we present to the native executable. Remember that sometimes there are no parameter names. That's where this is actually all stored. So if you look at the parameter map, there are two elements in the parameter map, one called interface and one called filter. And that means that there are two parameters surfaced, and we now can map that parameter interface into its original name and its original position and all the rest of it. In this particular case, the original position means 0, means it's the very first thing after the executable. The position that we see here, that number just simply means it's a named parameter. It's not positional from PowerShell's perspective.
Gotcha. Okay, so from PowerShell's perspective, since we have a named parameter, the position doesn't really matter.
Correct. And from our perspective, and the way I created this, is that minus interface is required if you want to provide a value for the interface when you execute the proxy. So you have to use minus interface. You can't just say invoke if config and then the name. You have to use minus interface. So we have to do that. And we actually do some parameter type checking. So if you wanted, for example, an integer or a float or a short or a string or something along those lines, you can actually strongly type your parameters, and you can see up here that this interface parameter type here, which is that guy, maps directly to this guy. So if I had put int, it would be an int there, and so that's stored in the parameter map. Some other interesting things are this argument transform and argument transform type. We provide the ability to transfer your argument from one shape to another. For example, if you wanted a parameter which was a hash table for your proxy function, but you needed to call the native application with something like name equals foo, a comma, name equals bar, or that sort of thing, that transform can do that. In this particular case, we're not doing any of that. We're just passing the argument unaltered.
But one thing I would throw out there about that transform, which you've added into the new 1.1 Crescendo, is I mean, it allows you to take some of the sting out of these native commands. A lot of native commands, they want an argument of like 1, 2, or 3, and you want to make it more human readable. That one, instead of 1, 2, or 3, it's sunny, rainy, or stormy. Oh, that makes a lot more sense. So that's one of the uses of the transform and that kind of thing. That's cool.
Yeah. The other interesting thing that's in the parameter map is this thing called no gap.
Yeah.
What that means is it takes the parameter name and the parameter value and puts them together without any spaces. It puts them together as a single argument.
And why
So,
would you do that?
well, there is a command called dd on a Unix system, and it would be shaped like this. I'll just type it in because I'm sharing. It would be dd if equals input file, of equals output file. And you'll notice that from PowerShell's perspective, this is a little strange, right?
Mm-hmm.
But I could create a parameter configuration that looked more like so you could do this: if input file, input, and minus of output. And from a transform perspective, all I would need to do is to be able to combine those two things. And the no gap allows me to do the following. So the parameter map would look like something like this. The original name would look like if equals. And
Oh, now I'm starting to see why you don't want the space after the parameter name, because you need it slammed up. You need the argument slammed up against that equal sign.
exactly.
Oh, that's
So
perfect.
that's the original. So you make the original name if equals, you set no gap, and then you provide the value, whatever the value is. It's a parameter, it's dollar input file, whatever. And so that means that you squish those two things together, and you get a single positional parameter for dd, because remember, dd doesn't, there's no parameter name there. It's, you just hand it the whole argument.
Got it.
And so that's what that no gap is all about.
I like that.
And in this particular case, the second second parameter, filter, has a new uh, um, property here, exclude as argument, which I showed you when we looked through the configuration.
Right.
So if we look here, exclude as argument is equal to true. It's
Yep.
not set. It by default it's false, so we don't need it. So exclude as argument is true. And what that means is that when we are putting together the arguments that we're going to hand to the native executable, if exclude as argument is applied to the parameter, it stays out of our argument list that we're going to pass to the native executable. So that means that we have a choice of what gets handed to the native executable. So I can do these sorts of things that we talked about earlier, where I want to be able to filter the results in the output handler. Now I can do that. Exclude as argument means that filter never sees its way to ifconfig. It's just kind of set as a variable in the scope of the proxy function. And that way I have access to it, and I can use it finally down here in the output handler. So here's the output handler for this. We're going to stream the output. And the handler is take the
yeah,
input.
there's the handler.
Yeah, there's the handler. Take the input, hand it to JC minus ifconfig, because that's the output I'm getting. Convert from JSON, and then I'm going to actually synthetically add a type to that JSON, that converted JSON now object. And then I add to it a filter that says, hey, only give me the objects that have a name that match filter.
Now, see, that's yeah, and so a lot of folks they write their commandlets so that the end user can decide on the filtering and all that, but there may be some pre-planned filtering, and that means you get to put the where object into the output handler and decide that pre-filtering. I'm so glad we added this feature.
Yeah, it can make things a lot easier for users, because they don't need to add that where clause at the end of their proxy. They can just do it. And in fact, if we kind of go and import the module, now I can say if config invoke if config, you can see that we have a lot of output here. Let me scroll up just a little bit, make sure that we can see it all. There we go. So it's a lot of output, and
And
you can
just
see,
so that I'm clear, this is structured output as an object that you've gotten because JC converted it to a JSON. Then you did the convert from JSON.
yeah, we can prove all that by simply passing it to get member,
Oh,
and
there we go.
we can see that. Remember, I added
Oh,
this, and I added the type name of crescendo.ifconfig. So now we have an object. We
yep.
have kind of a custom object. It's all note properties, because that's what convert from JSON does. It provides you all of this stuff, and so this gives you all the values. What that means, though, is that I can now say, give me, and if I say interface en1, that's now just that's just the if config for ef1. But what if I did something like this? I want to say, ooh, I want to see all of the interfaces that have en in them. So what I would do is I would do something like this. The star, that's wildcarding. And it would say, hey, look, the en doesn't exist.
Oh, I didn't get
Just to,
that globbing feature of PowerShell or whatever. I didn't get the the asterisk being the global wildcard search.
exactly. And I didn't implement the filter with wildcard. I did it with regular expression, but we'll see in just a second. Before I get there, I did want to say that we just produced an error. So we can
Oh
now
yeah.
use all the PowerShell tools to kind of determine the
Oh yeah.
errors.
See, and because of the way you're doing the errors, this is going to come from that native. This error is going to actually point to that native command, though, right? It's not going to point to
Yeah,
some.
we can see that in the position message. We can see that it came out of invoke if config, and if we go look at the error, it says invoke if config interface en star does not exist. So that's coming straight, that is some of Crescendo. That's some Crescendo magic in here, which we'll get to in just a second. But but because I added that filter, I can say invoke instead of interface en. I can say filter en. I'm going to just pass it to a table so it stays tidy.
Oh, I think you got file.
Oh, I did. So now I have the en.
Oh yeah.
And so that's much easier. That may be an easier sort of experience.
And actually, when I've run if config in the past, I've always wanted to do that. So and get a
Right.
nice clean screen. Look at this. And it's all an object, so I can actually work with this data. Oh, I love this.
It gets a little bit better if I can, it just as an aside, we can hook this all up into our formatting, because now we're emitting something that looks like it has a format. So if
You
I
can do your
say
own custom formatting on top of that. Yeah.
exactly. So now if I go and say, I want to make sure that the formatter has a name and the state and the MAC address adder and the IPv4 address adder and the IPv6 adder. That's what I want it to look like. Now I can use a tool that's part of the format tools module to create a configuration, new table format, and we're going to make it a standalone file. And what that does, it will create a formatting file that I can use. And then let's see, we'll save that away to ifconf.format.ps1xml. And now I can say update format data. And now I can just simply say invoke if config built en, and I get my formatting.
Oh, that's amazing. And just so that everybody understands, if you haven't worked with doing custom formats on maybe functions that you've written in a module before as commandlets, this may look a little strange. But this is again a part of PowerShell. It's been a part of PowerShell for a long time. That's the ability to create custom formats. on your commandlets. And what Jim just did is used a really cool tool, because this used to be a lot harder to do. This cool tool, new table format, is available on the PowerShell gallery in, what was the module name, Jim?
Format tools.
Format tools. That can really make creating your own custom formats on top of that even easier. Boy, I just love that. That's really cool. Thanks for the aside.
Sure. The tool actually creates this big blob of XML. And it
Yeah,
has
which if anybody has done this in the old days manually, you had to go find some of this XML, copy it, modify it, edit it, all of that stuff. You've made it a lot easier with
it
new
wasn't
format table.
it wasn't great. Yeah. So that's just kind of an aside to kind of go through there. So there we go. There we have our output handler now we're going to pop back to the code in the module. Now that we know that we can make this look great, now we're finished with the begin block. So we're going to take a look at the process block. The process block is where it gets the chewiest, because we need to convert all of the parameters that we got in the above. We need to use the parameter map to determine whether or not there are default values being used, or whether a parameter is in use. We have to kind of go through all of the parameters that we have and determine what parameters we're going to bundle up in a package to hand to the native executable. So the first thing I do is I have this PS bound parameters. I create this variable PS bound underscore PS bound parameters, and one of the reasons I do that is for debugging. If you try to debug all this and you're using the default $PS bound parameters, there'll be some trouble in getting access to the variables, since they're kind of in use in flight. So I save a couple of these things away so they're easier to deal with. And what's happening here is we're walking through and looking for the default value attribute, and this is where that's where I'm using these default values. So I'm using that attribute so I know I can look at the parameters and know whether or not it had a default value. So if the user didn't do anything with it, I need to go get that default value, but I need to know that they haven't, that it's a default value. And so what I wind up doing is I do a couple of lines there where I add it into the bound parameters dictionary, so I can then get access to it.
Yeah.
At line 89 is where we start constructing the command argument array. The way Crescendo works is it constructs an array of arguments, string arguments, because that's what native executables need. They need strings. They can't use the objects that we have. If you actually were to hand an object to a native executable, what will happen is we'll call toString on that variable and then hand that to the native executable, because you can't hand an object to a native executable. It's only strings only. So I have to create an array of command args, and this is where I'm really doing that. So, and here, the next line, I'm making some adjustments to that list. I'm adding some new values into that. We want to make sure that these are the built-in parameters, and these are the kind of the parameters that PowerShell is using internally.
Yeah, those common parameters: debug, what if, confirm, verbose. So you're bringing those in. So again,
I have to figure out
PowerShell experience.
Exactly, because I need to know in the next line whether or not the user has asked for -debug. And if they have used -debug, I will I will go into the debugger right then and there. I'll just simply say, you want to debug, I'm going to let you take a look and see what's going on in there. The next line is now where we need to start constructing our parameter arguments that we're going to hand to the native executable. So for each one of the bound parameter keys, each one of those things, where it is not applied to the executable, then that means that there are some commands which have a command and a subcommand, and those subcommands may have subcommands. Docker, for example, is one of those things where it's Docker run and then a bunch of arguments. But you can actually have an argument for Docker, like Docker minus debug run, or Docker, so there are parameters, and I need to be sure that I'm building up the right list of arguments what I want to hand off to put in my argument list. So I exclude the ones that apply to the executable. I exclude the ones that are that you asked me to exclude.
To exclude those special ones like filter.
Right, exactly. And then I also sort the object by the original position. So if you know, some native executables have an ordered list of arguments that have no names, right? So ifconfig doesn't do that, but there are certain ones where you need to have the interface followed by a class followed by something else. And so if you have implemented those, I need to put those in the right order.
Yeah.
And so I have to sort that by the original position. If it doesn't matter, all the original position means will do is it will just kind of do them as it finds it. So it doesn't really matter. If the thing says it doesn't matter, it doesn't matter. And that's why original position doesn't actually have to be accurate with regard to exact original position. It just needs to be accurate with relative position. So if you need something at the very end, give the original position as 100. And if something needs to go at the beginning, make original position 0. And if you need something to go somewhere in the middle, make it original position 50. It doesn't really matter. I'm just sorting that just to make sure that I line them up. Now I go ahead and grab the parameter value. So that's something I need. I'm going to use that in a bit. And we take a look a little bit. This is where it gets more and more chewy. If the value is a switch, so if you have a switch parameter in the PowerShell declaration, and there is if it has an original name, then it's going to add the original name as into the command arguments. So if it's minus quiet, that's a switch, because you would have defined that as a switch minus quiet in your declaration, in your definition, in the configuration. So I need to not provide a value if it's a switch parameter. So that's what this is doing here. If there is a missing value, then I simply add that missing value into the command argument right then and there. So there can be, it may be a parameter that has a value, but only if it's missing. So I have to make sure that gets in there. So if the switch is used, or if the switch is not used but it has a default missing value, I have to add that into the argument list, right? So it gets really tricky. Here comes the next little bit of business where we have to take a look at no gap. If there's no gap, I need to take the value and the parameter, and I need to construct the argument that I'm going to add to the argument list, the argument collection. And so I call the transform with the value, and it's in charge of giving me the values that it gets. So if you have, for example, a hash table, if you have an argument transform, if your parameter type is a hash table, that means you're going to get, at open brace 1 = 1 and semicolon bar equals 2.
Right.
Then you're going to have to construct your transform has to construct that into 1 colon 1 and foo colon 2, whatever your transform does. And I will add those to the command arguments. So it gets really, really tricky. And if you have no gap, it means and you have a transform, you're in charge of putting that all together. If the argument is, if you don't have a transform, the default transform, by the way, is just $args. That's what this is. So if you're using the default transform, here's what I wind up doing. I say I'm going to combine into the format this thing, and then I have you have to make sure that we quote things if there are spaces. So there's extra quoting here. Then what we do is we simply say, because remember that we had this format here, we simply say, here's the original name and here's the value, smoosh them together. So that's where you'd have the DD equals as the original name, and the value would be input file, and it would squish it together into if equals input file. And then it adds that to the command arguments. It's very, very complicated, but once you start if you start taking a look at it, it's pretty it's pretty straightforward, really. It's one of those things that there's no other kind of way that you could do this and manage what have you. If you're I said, if you have spaces in your argument, that means that when we were to hand it to the executable, it would see a space and it would think that's a new argument. So we have to actually quote all of that. So now we don't have a gap. Here's the original thing. This is the normal case. If you have an original name for your parameter, we add it to the command args. That's just like that. And then if it's an inline transform, then we actually figure out what we're going to do from a transform perspective, whether it's inline or whether it's sometimes it could be a script. So we just call the script, or if it's a function that you've got made available, it's a function. Otherwise, I need to turn it into a script block, and so I can execute it. Then we execute it and add the result into the command args. So now I'm building up again. I'm adding to the command args the array of arguments that I'm going to hand off to the native executable. Lastly, in line 133, nulls don't make sense to a native executable. It's just a blank. There's no space. It's not an empty space. It's not an empty string.
Oh, because empty spaces will make sense, but just a null. Yeah, there's nothing to act on with a null, right? Null is just null.
Yes, exactly. And your transform might actually try to add a null, and we have to get rid of all of those.
Because you can't feed those to the native command.
We can't feed those to the application.
Okay.
If you hand it back an empty string, quote, for example, that's preserved because that's actually not null. That's an empty string, so it's treated differently by PowerShell. So I get rid of those. I get rid of all those nulls. Now, so we've made our command argument array. We have just tidied it up, cleaned it up just a little bit. Again, if you've hit debug, if you've used -debug, I'm going to stop for you. So you could go from one place to the next. So you could kind of inspect. Really, the reason that this second wait debugger is here is because you could stop at the earlier spot, hit continue, and then you can actually inspect the command args. And that's one of the reasons why I put that here. Finally, pardon me, if you use -verbose as a parameter, I'll write some verbose stuff. So I omit the command you're going to invoke, and that's actually hard coded because I know what it is when we constructed it. And then I output the command args and all through write verbose so you can actually see that. Starting on line 139, I'm starting to go get the output handler. So I know what parameter set I'm in when I'm invoking the proxy.
Yeah.
So I go get the proper output handler for that parameter set, because output handlers are based on parameter set.
Yep.
So if I don't have a handler set, if the handler set comes back, if it's null, then I actually just use the default. This is kind of a in case that you don't have an output handler whatsoever. So you don't have to have an output handler defined, and this is the thing that handles that. I will use it if you provide it, but if there is not one in the configuration, I will use our default handler, which is always present. It's part of the boilerplate. It's part of the generated boilerplate. Then I actually go grab the handler from that object, and then I have a should process line. So sometimes you're going to wrap something that's changing state, so we need should process.
Oh, yeah.
In this particular case, it's a get, so there's no should process doesn't really worry. It doesn't kind of apply, but it's no harm, no foul sort of thing for using it in this circumstance. We just since support should process isn't defined as part of the commandlet attribute, we just invoke it. And then finally, we're now going to try to invoke the command. If I can't find the command, I'm going to throw. I cannot find the executable if config. So that's my last ditch effort to throw. This you could argue that this could be in a different place, and it's not a bad argument. We'll have to see what our customers think. So we're about to start thinking about invoking our program. So that's what line 149 is all about. If the handler is a streamer,
Okay.
and the
Streaming
handler
output.
is null, which is true when bypass is used as the handler type. So if bypass is set as the handler type, we will make the handler will be null, and that means we just invoke ifconfig with the command args and do nothing. We don't save the errors. We don't do anything. We just invoke it kind of bare.
Hence the feature of bypass. I mean, that's what you intended when you bypass, is just to go past all of that stuff.
Correct, exactly. And so that's the reason why we have that supports. There's a couple of programs, one of which slips my mind. There's a color program.
Yeah, Pastel.
Pastel.
Yeah.
It provides. It knows whether it's in a pipeline, and if it thinks it's in a pipeline, it behaves differently than if it's not in a pipeline.
Yeah. Again, thanks to the community for pointing some of this stuff out, because one of the things that I hadn't noticed, I don't think I had realized, is that some commands change their output if they know that they're piping. Pastel is a great program. Matter of fact, we have an issue about it that we fixed, and we've talked about it, used it as an example recently when you and I were talking at PowerShell Summit. But Pastel, when you run it, will show you a pretty picture of a color schematic of different colors. But if you take Pastel and you pipe it, put a pipe character, instead of showing the picture, it just turns that into the color numbers, which is what you would want. But when you use Crescendo with something like Pastel, because you have an output handler, you don't get the pretty display. With bypass, then you get the pretty display for the command. So bypass lets you control that. I think that's awesome.
Right. And so if we don't have, if the handler is null, we do that. But otherwise, what we do is we call the handler, and this is where we use push crescendo native error. So if we can kind of deconstruct this line here, if config, we're going to invoke the if config. That's fine. We've packaged up the command args, and now we take this error output and we multiplex it into the standard output error. Standard output. So we take standard output and standard error, and we squish them together, and we hand them all to push crescendo native error. And if when we looked at Crescendo native error, remember, we can go, in fact, to do that, we'll go up here and take a look at push Crescendo native error. There it is. We look, if the input, if the incoming object, if the incoming thing is an error record, we enqueue it into our native error queue. Otherwise, we just emit it.
And that's how you separate, if it's just regular output, it comes out. If it's an error, it gets enqueued to be displayed later as an error.
Correct. And so that's what we do in order to capture all the output from the native executable, both standard error and standard out. We collect all of that and we push those things in the native that are errors into that queue, which we'll get to actually later. And then we call the handler. We invoke the handler, which is the handler that I showed you up above, which is the take the output, hand it to JC, convert it from the JSON into an object, add a particular type name to it, and then hand it to the filter where object name underscore dot name equals whatever the filter was. So that handler gets invoked here. And that's in the streaming case. If we are not in the streaming case, what we do is we simply take all of the results and all of the errors. We enqueue the errors in push Crescendo native error, and then we emit the standard output and hand it into the result, and then invoke the handler with result as an argument.
Gotcha.
So we don't stream the result. We don't stream the result anymore. We just hand the whole thing off as a package to the handler and say, here's your argument. Do your thing to the handler. And that's how and that's what we do depending on whether we're streaming or not streaming. If you are streaming, your handler, well, even if you're not streaming, your handler always has the opportunity to retrieve the errors out of the queue directly, manually. You can do that because it's just another script block, so you can implement your error handling in your output handler now.
And that's what we were saying earlier about you handling your errors if you wanted to handle them differently rather than send them out. Okay, that's awesome.
Yeah, we can the user can the writer, author can do whatever they want with their errors. They can, like I said, they could log and they can reconstruct and call some other application. They can do whatever, whatever. You now have access to those errors, and you can manipulate them or whatever you want. So that's the way we call the native executable. And then finally, we call by default pop Crescendo native error and emit as error. And so that means that we are not going to let any errors not be displayed. We're going to make sure that the user sees those errors.
Sees it.
And as you remember, in our handler, we don't do anything with the errors any errors that get generated. So when we did this, invoke en234, that should produce an error, and the user may not know it if we didn't display it. So we actually have to display it. Oh, in this particular case, it's not filter, I should have said interface.
Oh, yeah.
If we use interface, this is actually, there were no names that matched en234, so it gave me no results. But if I say interface, this will produce an error because if config en234 produces an error. And there we have our error. So if we were to just run if config en234, so this is now the native executable.
Oh, yeah, yeah.
And
what I love about this is that it's wrapped up. It looks like an error you should expect from PowerShell. It's colored red. It ends up in the get error. It's in the $ error stack. I mean, this is just what you would expect.
Yeah, so this makes this kind of, again, it's all about having the native executable play nice in the PowerShell ecosystem, ethos, the way PowerShell likes to work. And that's kind of how this all gets constructed. And finally, I just wanted to mention at the end of this command, this proxy function, we have put in all of the documentation that you provided for us. So we provide the synopsis, we provide the description, whatever, all of that stuff that you can define for your help. So that means you can say get help minus full invoke if config. You can see, there you go, filter.
Yeah.
Look, that shows you what the default value is. This could be a wildcard if you wanted it to be. There's the other interface, a specific interface to query. So it provides all of this information because we construct the comment-based help for the proxy.
Wow, this is amazing. It's just amazing. It's chewy code, right? It's chewy
Definitely.
code, but it's readable code. And with, you walking me through all of this and being able to understand this a little bit better, I'm understanding how to write the configurations better now. And I'm understanding how, I could go in here and I could edit my help file. I could make some changes. If I wanted to add a progress bar, I could do that. But I got to be honest with you, I don't know if I want to do a lot of modification in here. I like the fact of being able to make my changes in the configuration file and just return the crank and everything happens, because I can crank a lot of stuff out that way. But being able to know more about what's going on in here and how it works means that I can troubleshoot it. I can, especially native commands work differently. I can figure this out. It's an amazing walkthrough.
Yeah, the code is segmented. So if you're having trouble with a particular aspect of what's going on, you can take a look at it. It's one of the reasons why I added the debug, the debug and verbose. So if I say invoke if config minus verbose filter, no, let's do interface en0. You can start looking at this. That's one of my verbose statements. There's my command arguments. That's just a single one, so I don't need to have more. And then I have this is coming out of the should process line. So and what if isn't supported because it's a getter, so what if doesn't make sense, but verbose still does. So that's the way we have it. And then you can tie it into the automatic formatting because we can provide that to you. You can even get more complicated. So state doesn't look like a collection. It looks like a comma separated set of strings. That's all. Those are all knobs you can turn if you like.
Wow. Just wow. Well, I can't thank you enough for taking the time to go through all of this. This is really amazing to be able to do this. And like I said, helps with troubleshooting, helps with extending what Crescendo can do. Let me ask you this, kind of a trick question. Now that we're coming out with Crescendo-01, and this is how Crescendo-11 works, what's next for Crescendo?
So it provides all of this information because we construct the comment-based help for the proxy.
Wow, this is amazing. It's just amazing. It's chewy code, right? It's chewy
Definitely.
code, but it's readable code. And with, you walking me through all of this and being able to understand this a little bit better, I'm understanding how to write the configurations better now. And I'm understanding how, I could go in here and I could edit my help file. I could make some changes. If I wanted to add a progress bar, I could do that. But I got to be honest with you, I don't know if I want to do a lot of modification in here. I like the fact of being able to make my changes in the configuration file and just return the crank and everything happens, because I can crank a lot of stuff out that way. But being able to know more about what's going on in here and how it works means that I can troubleshoot it. I can, especially native commands work differently. I can figure this out. It's an amazing walkthrough.
Yeah, the code is segmented. So if you're having trouble with a particular aspect of what's going on, you can take a look at it. It's one of the reasons why I added the debug, the debug and verbose. So if I say invoke if config minus verbose filter. No, let's do interface en0. You can
Yo,
start
yeah.
looking at this. There's my, that's one of my verbose statements. There's my command arguments. That's it's just a
Yep.
single one, so I don't need to have, I don't need to have more. And then I have, this is coming out of the should process line. So and what if isn't supported because it's a getter, so what if doesn't make sense, but verbose still does. So that's the way we have it. And then you can tie it into the automatic formatting because we can provide that to you. You can even get more complicated. So state doesn't look like a collection. It looks like a comma separated set of strings. That's all. Those are all knobs you can turn if you like.
Wow. Just wow. Well, I can't thank you enough for taking the time to go through all of this. This is really amazing to be able to do this. And like I said, helps with troubleshooting, helps with extending what Crescendo can do. Let me ask you this, kind of a trick question. With this coming out in 1.1 of Crescendo, what's next?
Well, we definitely want to hear from our customers. We think that we're building a tool that's really useful, but in a vacuum, we don't know. So we definitely want to hear uh, and get feedback from the folks that are using it and figure out where we can, what needs to work better or what we need to add from functionality perspective. So it's really up to you guys to tell us what we need to do next.
And I would just add on to that, Jim, that almost everything that we did from 1.0 to 1.1 was all from community feedback in our GitHub repo. Some great comments, a lot of great help and assistance out there in conversations that helped us make decisions about what we needed to add. And of course, we look forward to doing that as well in the future. Jim, thank you so much for your time. I really appreciate it.
Sure.